I'm going to set you a few questions looking at calculating the equation of a tangent at a point. What I want you to do, read the questions, have a look at them, pause the video, go away and have a ping at them, then come back and look at the work set of solutions I'm going to provide you with. So, here they are. First one, find the gradient of y equals 1 over x squared at the point x equals negative 1. Second one, find the points where the gradient equals 9 on the curve y equals a third x cubed, and then find the equation of the tangents at these points. And then the third one is, I want you to prove that the gradients of all tangents to the curve y equals x cubed minus 6x squared plus 12x plus 1 are always positive. Have a go at these questions and then come back and check your answers. So first question, find the gradient of y equals 1 over x squared at the point x equals negative 1. Now remember, the key principle we've been looking at so far is that the gradient is equal to the derivative of the function, whether that's f dashed of x or dy by dx, whatever version it wants us to look at. That's the key thing we always have to remember. So for the gradient of this function, we have to take the derivative and then figure out the derivative when x is equal to negative 1. Now, when we're taking derivative, think back to when we covered the basics of how we do that. We have to make sure we transform this properly. So we have to write it as y equals x to the negative 2. Remember, we can't have 1 over the x squared. We have to put it with the power in an index like this. So what we then do is we do dy by dx, and that equals negative 2. So bring the power down, then reduce the power by 1 to the negative 3. Rewrite that as a fraction like this that we can use then at that point. And we get negative 2 over x cubed. Now, this is where we start our substitution. We want it when x is equal to 1, so I then say, therefore, x equals negative 1, and we calculate our gradient. We get negative 2 over negative 1 cubed. Now, negative 1 cubed is just negative 1, so I get negative 2 over negative 1, which gives me 2. So my gradient at that point, when x is equal to negative 1, is 2. Now, if we were asked for further information or to get the equation of the tangent, we'd substitute in here, get our full point, and then use y minus b equals mx minus a. We're not in this case, so it's just that. That's the final step for this one. Second question was find the points where the gradient is 9 for this curve, and then the equations of these tangents. So again, we have to start thinking what it means when it says the gradient. Gradient is rate of change. So we then know that the gradient is equal to dy by dx. But in this question, we're told it's equal to 9. So what we want to do is set up an equation where dy by dx equals 9 and solve it. So we have to take this to begin with and take the derivative. So we know dy by dx equals 1/3, bring the power down, 3x, and then reduce the power by 1. Simplify it now and we get x squared. So now we set up our equation and we solve it. So what we know is that x squared equals 9 based on this bit here. So if x squared is 9, x equals 3, or negative 3. Remember back to the video when I talked to you about the one there where we had to take the positive and negative value into account for a squared. We have to remember to do it for this one as well. So it's x squared is 9, x can be 3 or negative 3. So that there is the x part. However, it wants the full point, so now we have to find the y part as well. So to get that, we substitute those into here. So to get the first y, when x is equal to 3, we do 1/3 times 3 cubed, which is 9. And when x is equal to negative 3, it's 1/3 times negative 3 cubed, which is negative 9. So I get 2 points. I get 3, 9, and negative 3, negative 9. So there, my 2 points right there, the answer for that first one. Then I want to find the equation of these tangents. So it's two separate equations here. So first one I'm going to do is the 3, 9. Again, use the formula y minus b equals mx minus a for this. So y minus b gives me y minus 9 equals m. Now remember the gradient here is 9. It gives you it in the question. So y minus 9 equals 9 bracket x minus 3. And then it's just solving this. So y minus 9 equals 9x, take away 27. Y equals 9x, add 9 to both sides, take away 18. So that's the first equation right there. Second equation is for the second point, so negative 3, negative 9. And again, same formula, you just have to make sure you take all the signs and bits into account. So y minus b becomes y minus minus 9. So it's y plus 9 equals m. Now we know the gradient is still the same, it's 9. Bracket x minus a becomes x plus 3, because again, minus minus. So y plus 9 multiply out the bracket gives me 9x plus 27. Y equals 9x plus 18. There you go, equation of my straight line now. So that's me got both equations of both lines. Key thing to notice, the gradient part is the same in both. All that's changed is your y-intercepts, but that's perfectly understandable. Third question was prove that the gradients of all tangents to this one are always positive. Now, to prove this, we have to figure out what it means by always positive. Always positive means it's bigger than 0. So what we want to prove or show is that the derivative, dy by dx, is bigger than 0, because it's the gradients of the tangents. Gradient again, derivative. So derivative has to be bigger than 0 for them to always be positive. So first thing we have to do is figure out dy by dx. Bring the power down, reduce it by 1. So this one here gives me 3x squared, take away 12x plus 12. And I know that I want that bigger than 0. Treat it like solving a quadratic at this point. Got a 0 on the right hand side, factorise and then solve. Common factor, 3 bracket x squared minus 4x plus 4 is bigger than 0. So that gives me 3 brackets x minus 2 squared has to be bigger than 0. Now we know that this is always going to be bigger than 0 based on what we've got written here. X minus 2 squared, that's always positive. If you square a number, regardless of whether it's positive or negative, it's always going to be positive. So what we then can say is, therefore, we know the derivative is bigger than 0 for all x. We've proven it. Alright, we've proven this is always going to be positive. This is the kind of characteristic you're looking for in a question like this involving the gradients. So, key skills we have to be able to take away from that with the gradient of the tangent. Know how to calculate gradient, derivative. Know that we're looking for a point. If we get given the x value of the point, we have to use the original equation to find the y part. We need both bits. We then have to make sure we're using our y minus b equals mx minus a formula to get it. And we have to remember key characteristics like this one, always being positive. How can we indicate that? Well, there you go. That's it right there for you.